Spring Security is a framework for modern web applications. Spring Security has this concept of an authentication provider, which is, in some way, able to provide a guarantee that the request being made is being made by somebody who has permission to make the request. This framework deals with this idea of an authentication provider. An authentication provider might, for example, take in a username and a password, it might take in a certificate, or it might take in a cookie that comes in from the request. There's a specialization of the authentication provider called the user detail service, which specifically deals with usernames and passwords, which are common enough mechanism for authentication that it's worth having this specialized framework for. Spring Security provides all sorts of integration with other identity provider systems. For example, Active Directory, LDAP, PAM, Kerberos, OAuth, etc. Usernames and passwords are one approach to doing authentication on the open web. If you've used an application in the last 20 years, then you've more than likely been hit with an HTTP basic prompt. A username and password gets sent from the client to the server, which then uses those credentials to verify that the party making the request is who it says it is. A slightly more sophisticated variant of this is to use a digest password, where the passwords are hashed but then sent over the wire. HTTPS, or TLS, is often used to prevent man-in-the-middle attacks by encrypting the data from the client to the server. Let's take a look at how to set up this very, very basic authentication scheme using Spring Security. Our first example is a simple Spring Boot application that will stand up HTTP basic authentication. If we do nothing and simply bring in the Spring Boot Starter Security library, Spring Boot will automatically set a default username for named user and print out a password to the console. And all requests can be authenticated using that printed out password. This is very convenient, but not suitable for production. We're going to go ahead and plug in a custom user detail service that can look up information about usernames and passwords from a database. We're going to use JDBC to do that, so I've brought in Spring Boot Starter JDBC, and I've brought in H2 for our example. The data will live in the database, and here's, for example, the two records that we have in our database. One for the username JLong, and the password in this case is Spring. One for the username named PWeb, and the password in this case is boot. Our user details service is fairly simple. User details service in of itself is just an interface, and it has one job. Given a username, var1 in this case, return a user details object. The user details object answers certain questions for the framework. For example, what is the current user's permissions? What is the current user's username and password? And is the account available? Is it locked? Is it expired, etc.? Answering these questions is fairly easy, as you can see here. We return the implementation using lambda syntax. So this is the username that gets passed in. We then pass in that username to the JDBC template, where we run a query and then use a row mapper to map the results that come back into objects of type user. User is a POJO DTO object that comes with Spring Security that implements the user details contract. So here, for every record that we see in the database, we extract the appropriate fields and then pass them on to the POJO, and then that becomes the implementation for our user details service object. To tell Spring Security that we're using our own custom user details, I have to set up a global authentication configurer adapter. This gives us the chance to plug in our custom implementation through injection. We do this in all the examples in this section, and so you should get familiar with this basic approach. This is how you plug in a custom authentication scheme. Other than that, this is a fairly simple example. We have public static void main, which is the standard boilerplate code you have in all Spring Boot apps. And then down here we have a simple REST service that simply returns a JSON object to the client consisting of an ID attribute and a content attribute. This is not particularly interesting in of itself. It's just to prove that we're able to access otherwise protected information. Let's run this example and see it in action. The application is now up and serving requests. Go to the localhost endpoint, and you can see that we're being challenged to enter authentication information to be able to access the service behind the scenes. We can use, as you might imagine, our two users, JLong in this case, and Spring, to access the information or access the web application. Go to the /hi endpoint, and there you go. There's our data. If we try this again in a new browser, we'll be prompted again. If we type in now, for example, JLong and foo, it'll ask us to re-authenticate. So it's clearly able to figure out that we're entering the wrong information, and it'll reject our attempts to access the service. Voila. That wasn't bad, but that's a fairly ugly experience for the user, albeit very simple. and it's also, as we mentioned, insecure. We've seen how easy it is to set up HTTP basic authentication from the service perspective. It's also very easy to use it from the client side as well. Remember, Spring provides the REST template, which is very, very convenient for making REST calls to other services. If ever you want to set up HTTP basic authentication on a service and you want to consume that service from a REST template client, it's fairly straightforward to send the username and password credentials in the request like this. You set up a username and password credentials object, set up a credentials provider object. This credentials provider comes from the Apache HTTP client library. We build up an HTTP client using a Fluid Builder API, and then we set the default credentials provider, passing in the credentials provider that we've just created, which itself is going to have the username and password credentials object that we've got. And then you get a closable HTTP client from that, and then you can pass that into the HTTP components client HTTP request factory. Rolls right off the tongue. And then you can pass that to the REST template. Set the REST template up and then inject it wherever you need to, and it'll automatically provide the authentication information that you've given it. This makes it very, very simple for you to transparently make requests against the REST service and not worry about passing in the security on every call.